Helping Learn, inspiring minds, building futures. Welcome to Helping Learn, where we empower developers and technical presenters to master complex concepts. This presentation will guide you through the core principles of object-oriented programming, OOP, in Java, providing practical insights for building robust and scalable applications. Object-oriented programming, OOP, in Java. Object-oriented programming, OOP, is a programming paradigm based on the concept of objects, which can contain data and code. Java is built upon OOP principles, making it essential to understand these concepts for any Java developer. Let's explore the fundamental pillars of OOP. 1. Access modifiers. Access modifiers define the visibility and accessibility of classes, variables, methods, and constructors within a Java application. They are crucial for implementing encapsulation and data hiding. 2. Encapsulation. Encapsulation is the bundling of data, variables, and methods that operate on the data into a single unit or class. It restricts direct access to some of an object's components, promoting data integrity. Understanding access control. Access modifiers are keywords that set the accessibility of classes, methods, and other members. They play a vital role in securing your code and controlling how different parts of your application interact. Modifier. Visibility. Where accessible public, everywhere, any other class private, within the same class only. Not accessible outside the class protected. Package plus subclasses. Within same package and subclasses, default, package private. Within same package only. Only accessible within its own package. Encapsulation and abstraction. While often used interchangeably, encapsulation and abstraction are distinct yet complementary OOP principles. Encapsulation. Data protection. Abstraction. Hiding complexity. Achieved by using private variables with public getter, setter methods. Achieved by using abstract classes or interfaces. Benefit. Focuses on what an object does rather than how it does it, simplifying system design and usage. Benefit. Ensures data hiding and protects from unauthorized access. It allows controlled modification of an object's internal state. Example. An animal abstract class with an abstract sound method, implemented by concrete classes like dog. Example. Person class with private name and public getName, setName. Classes and objects. The building blocks. Classes. The blueprint. Objects. The instance. A class is a template or blueprint for creating objects. It defines the properties, fields, attributes, and behaviors, methods, that objects of that class will have. Think of it as the design for a car. An object is an instance of a class, representing a real-world entity. It has concrete values for the properties defined in its class. Using the car analogy, an object would be a specific car with a defined color and the ability to drive. Example. The car class defines a color property and a drive method. An object myCar would be a specific car, for example, a red car that can be driven. Methods and initialization. Methods define the actions an object can perform, while initialization ensures variables have appropriate starting values. 100%. Methods in Java. Variable initialization. Methods are blocks of code that perform specific tasks. They can accept parameters and return values. Variables can be initialized in several ways. Default initialization. When not explicitly assigned, e.g., int defaults to 0. Instance method. Operates on object instances. Static method. Belongs to the class, no object needed. Explicit initialization. Assigned a value at declaration or in a constructor. Static initialization. Static variables initialized when the class loads, via a static block. Instance initialization. Instance variables initialized in the constructor or instance block. Constructors. Object creation. Constructors are special methods critical for creating and initializing objects. What are constructors? They are used to initialize new objects. Their name is always the same as the class name, and they do not have a return type, not even void. Default constructor. Automatically provided by Java if no other constructors are explicitly defined in the class. It has no parameters. Parameterized constructor. Takes one or more parameters, allowing you to initialize object properties with specific values at the time of creation. Copy constructor. A specialized constructor that creates a new object by copying the values of an existing object of the same class. Constructor chaining. Constructor chaining allows one constructor to call another constructor within the same class using the this keyword, or a constructor in the superclass using super. This technique helps in reducing code duplication and improving maintainability. Example. The person default constructor internally calls the person string name int age parameterized constructor to set default values, avoiding repetition. Class person string name int age person this unknown 0 calls parameterized constructor. Person string name int age this dot name equals name this dot age equals age. This promotes cleaner code by centralizing initialization logic. You can also chain constructors across inheritance hierarchies using super. Summary of OOP concepts 1. 2. Access modifiers. Encapsulation. Control visibility, public, private, protected, default, to manage what parts of your code can be accessed by others. Bundles data and methods into a single unit, protecting data through private variables and public getters, setters. 3. 4. Abstraction. Classes and objects. Hides complex implementation details, exposing only essential features. Achieved via abstract classes and interfaces. Classes are blueprints, objects are instances. The foundation of OOP structure. 5. 6. Methods. Constructors. Blocks of code defining behaviors. Can be instance-specific or class-wide, static. Special methods for object initialization, ensuring proper state upon creation. Can be chained for efficiency. Mastering OOP for future success. Control and security. Access modifiers and encapsulation provide robust control over data and application security. Simplicity and reusability. Abstraction simplifies complex systems, while classes and objects promote code reusability and clarity. Efficiency. Methods enable organized functionality, and constructors ensure efficient object initialization. Next steps. Explore advanced topics like inheritance, polymorphism, and interfaces. Visit our website, https://helpinglearn.lovetoblog.com/. Contact us, helpinglearn1@gmail.com. Follow us, https://whatsapp.com/channel/